All right, so the notes have begun, but I gave you a front and back sheet of paper because I noticed when I assigned the homework that 17 and 18, sorry, going the wrong way, I cut and pasted this on a Word document and then printed it for you. The reason is so you don't have to create your own chart. You don't have to write it out, saved you that writing. But also, if you had a hardcover book, these charts have to be filled out from the previous page's chart of information. So now all you have to do is open up your Chromebook and have this chart visible. And then you can fill out your frequency tables. And they're right there, right on that piece of paper. Got it? Isn't that nice? Okay, yes. Boy, there's a lot of negativity in second hour. A lot of anti-Mr. Samuelis trying to help people out. And, you know, it's like, here's $1 million. Forget you, Mr. S. I want $2 million. You're such a jerk. All right, anyway, sorry. Did you hear all the negativity? Is all the shots fired already? All right. And then, so 17 and 18, try to draw your, okay, listen. This is based off of yesterday's information, so it's a histogram that you're drawing. Shh. And we did that yesterday. And then from there on out, I put 31 on the bottom of page 1 because 31 is just looking at a picture and then answering a question. So I was trying to get to 31. And then that does deal with today's stuff. There's 31 children vaccinated, blah, blah, blah. And then after that, we do have to make creations of pictures. So flip over to the blank sheet on the back. Try to fit the rest of the homework on the back. And I think you should be able to do that. Okay? So I tried to do that. It was an idea that hopefully most of the positive people in my class appreciates. All right? Can't make everyone happy, though, can you? All right, so now, take what you want because this is kind of Mickey Mouse. It is kind of pretty easy to start. This is grade school stuff that, my kids would probably even understand how to read this chart because that's how it starts. But they do have one question where you do have to create your own line graph too, so just make it look nice. So line graphs are really pretty decent to be used when you have behavior over time, where the x-axis or the horizontal axis represents units of time. And over these units of time, what do you see happening in some sort of scenario, which is represented by the vertical axis. So with all that being said, that's what a line graph is usually best used for. So here's our first little representation of this. Picture given. So that's why I say this is grade school stuff. I can understand if you're not writing this, if this is too simplistic. The percent of American people, so that's what the vertical axis is, the percent of people at a given year that make over $40,000 per year is shown in this line graph. Now, a lot of times these line graphs, they just have those points given, and then they have solid lines as opposed to these squigglies. What these squigglies must represent is the data. Actually, there is more points, like year to year, kind of implied in there. So just be aware of that, trying to erase that. A lot of times a line graph is each point has a direct line connecting them, not these squigglies. So the squigglies must imply that there's more data per year as well in there, and we'll use that in this scenario. So then, simple little question, and I'm not even going to ask you. I want to get this over with because it's easy. 1980, that's this year. This is simple graph reading, and that point should be like right above 1980. It's a little bit off. What percent of Americans make over $40,000? So what we have to do is visually see this and then kind of go. It looks like it went a little bit up. So do you think it's 15%? Nah, I think it's somewhere around 12. I'm going to say 12 because it looks like I raised that line a little bit as I tried to look across. So obviously as a teacher, there's a range I would accept. I'd probably accept up to 15. I would hopefully think you would go above 10 because that point is above 10. You get the idea. Explaining it too much. 1995, that's supposed to be the data points there, so that is supposed to be 1995. And then try to do a better job here of reading. This is what your eyes have to do. All right, and I kind of look like a little decrease at the end there, so I think it's more like 35%. I kind of fell down there when I went across. Again, there's a range I would accept. So you get the idea. Between which years did the largest increase occur? It looks like I have two possibilities. One is, it looks like from 1990, we're somewhere around here. Yeah, it looks like it's right at 20. To right about here. So between which years, and I'm going to go by fives because the data points are by fives, even though there's those little squigglies. So between which 5-year intervals, I will add that in there, does it look like we have the most increase? First of all, what's that increase? What percent increase is it from 90 to 95? What does that look like? Come on, answer the question. Almost 20, but not quite, so probably right around what? Let's say like 18%. That's what I said last hour. Or what about this one? This is probably the other one that looks like a big increase. And then just looking at this, I think we could see, what does that increase look like? About what percent? That's about 10%. So this looks like the winner. Between 90 and 95, biggest increase. Yeah. All right. And then example 1D, what was the percent increasing, decreasing, or constant between? Now this is a little bit tricky. Here's 1980. We're supposed to go by years of 5. And then that means that this is like 1982. What does that look like? Did it increase or decrease from 80 to 82? Well, 82 is lower. So that looks like it's decreasing from that year to the next for those two. Then 88 to 90. Well, here's 90. Here's 88. What does it look like? Looks like an increase. Mickey Mouse stuff. But the idea from one year to the next, the thing goes up. So the numbers are going up. This is basic stuff you did in Math 3 as well with, equations and graphing equations and then analyzing the graphs. Okay, good enough? All right, this is where I need your help with the calculator. But go ahead and take a minute to take this information down if you are a good note taker. And then this is what 2 of the assignment questions. I think 2 are line graphs, 2 are pie charts, and then the last 2 questions deal with when would I use a particular chart given a situation. So let's stick with the pie charts here. It's useful for displaying information about budgets, time use, so on and so forth, or anything that you can say, all right, we have 100% of something. How can we break that up into categories that add up to 100%? I already filled that in, and I think this is the best thing, and we are going to have to do this. A full circle is 360 degrees, right? So what we're going to do is break down this survey, and then from this survey, we're going to figure out the size of the pie in the pie chart of each part of the survey. So without a word problem, I'll just verbalize it. Hey, you survey 640 people. I'm pointing to that in class. I'll circle it down here. And then you survey, hey, what's your number one, if you had to pick one, genre of music to listen to? 172 of those 640 said rock. 163 of those said country, so on and so on and so forth. Okay, so the survey's done for you and given. Now we want to break this down into 2 parts. We want to break it down into this. Where I need your help. Come on, let's get this over with so you can get me to shut up. Percent of listeners. And then from that, what sector degree should be used to show on the pie chart? Because I think we can then make a good size pies, the correct size pies. Like, for instance, what degree measure is this? I think everyone is going to know this. And if you don't, I don't think you belong in this class. What's that degree measure about? 90. Who said 100? Okay, I tried for 90. Okay, so everything can kind of be compared off of that, and watch what I do. Another anti. Whatever he does, I'm going to answer it wrong and not support him. Okay, so you ready? Who's got that calculator out? You going to be helpful? All right, good smile too. All right, 172 divided by 640. Give me like 3 decimal places. 0.269. Now, what am I going to do with this 0.269? Blah, blah, blah. She's got that on her calculator. What am I going to do with that to find out what the degree sector should be? I take that number and multiply it by what? Not 100. What's a full circle, everybody? 360. That 0.269 represents what part of the 360 this represents? So what should the angle measure be for the pi? So what is 0.269 times 360? 96.75. That's how I feel sometimes. All right, especially when my computer does that. All right, go ahead. 96 point, let's say 8. Now, we can draw that right away. Okay, so we said 90 was this. So don't draw that. I'm just saying, okay, I can visualize that's 90. So 96 is just a shade bigger than that. And you don't have to be perfect. But at least it gives you a ballpark, and you should be able to do it. All right, and then I'm going to pick a color to shade that in. And then I'm going to go ahead and label that. 96.8 degrees, or I should say, like, this is what I should say. I did this last hour. That doesn't really make sense in the real world. In the real world, what makes sense is what percent of people do this. So 26.9%. Sorry, first hour. Like rock. All right, I know you could do this with the percentages too, but they do ask you for the degree measures as well. So I would appreciate, and you actually have to anyway on a test. So, all right, next one. 163 divided by 640. Could you help me? 255, blah, blah, blah. And then we're going to take that and multiply that by 360. I don't feel like rewriting it. And you have it on your calculator screen anyway. Just hit times 360. What do you get? 91.8. Now, 91.8 degrees. And we'll use that. Did you round that 255? Did you round that 5 right? Okay. Because I'm doing something different. Now, when you have this, you would have to agree that this is 90-ish. Actually, it looks like it's a little bigger than 90, which is good for me because this is 91. And then, uh-oh, I lost that line. And anyway, 91 plus 96 is 187, which is greater than 180, right? Right, everybody? So that would be 180 if I went straight across there. I feel like I went a little too far, so look at how shaky I am. It's old age, everybody. All right. And then what I'm going to go back is go to that percent, 25.5% of the people, like country. And you get the idea. And I think I could stop the video, do the rest offline, and then, forget it. You can fast forward the video if you're bored. So let's keep going. 42. Let's go to 42 divided by 640. 0.0656, right? I'm just trying to get that in my mind to round it right. But then go ahead and take that full decimal and multiply it by 360. Thanks for your help, by the way. 23.63. Okay, 6.3. Okay, this one's tougher. Wouldn't you agree that this is 90-ish, right? Something like that, right? Now you might have this luxury if you have a pencil, lightly draw this. So then what would that make this angle measure? What did I just cut 90 degrees in? Half. So what's this angle measure right here? 45. What do I have to do to 45 close? I have to cut it in what? Half. And then this is how you can get these pies to be at least, relatively speaking, close to the angle measure that you want to emulate. All right, and I think I've done that. And then what I'm probably going to do, because this is, I'll put it in there, 6.6%. But then I might have to draw an arrow out here and label it as classical. And you'll see that a lot with pie charts, the arrowing, because the pie is too small. All right, and then I'll go blue, even though it's going to be kind of tough to, there we go. Just do this. Good enough. All right, and then we can proceed on, make this go faster. 201. 0.314, and then multiply that by 360. 113.1. All right, so if this is like 90, then 113, by the way, that's oddly enough 23 larger. Actually, you know what I did last hour? I went off rock, because this is 90, and then I need another 23, which is the same size as this, which is weird. So that would probably be pretty good. All right, and then you don't have to be perfect. I'm not going to get out a protractor and measure. Isn't that what a protractor does? Measures? Wrong. I just did this wrong. I want the percents. 31.4% of the people do talk radio. Used to do talk radio. Meaning I used to listen to it. Wasn't a talk radio person. It'd be cool though. I don't know. I wanted to see talk radio. It's a dark color. And then the last one, let's just get that last percent down and then get these notes over with. 62. Not rocket science we're doing here. What'd you get for that last one? 0.097. By the way, all of these should add up to 1, equaling 100%. Then when you take 0.097 times 360, what do you get for that angle measure? 34.9. And then we're just going to have to accept that this is 34.9 degrees at the end. Looks bigger than 23, so good enough. These all should add up to 360 degrees. All right, and that's what we see here. And I think I could get that in there, pop. And it's 9.7%. Sorry, YouTubers, about my messy writing. It's very hard to write on the screen. And actually, I do have difficulties writing, I guess, in general. Okay, I just didn't want to go over pop because that's a very dark highlighter. You guys okay over here? All right. Seem to really be enjoying the math. All right. Now, I worded this perfectly. Well, yeah, bragging, right? I worded this to kind of emulate what we're going to do all the way throughout May. This was a survey. What if they surveyed, no offense to them, but a bunch of people in a retirement home that are 80 years old? Is that a nice sample of a population to represent the rest of the world? Or do they have different ideas and different thought processes and blah, blah? You know what I mean? So this is why I worded this, and I wasn't, making fun of it. I'm just saying, how was the survey done? What was the population? We have a chapter about that. When you do a survey, is that survey really emulating what the rest of the population would actually feel? And there's a science to it. Anyone ever hear of Nielsen ratings? Nielsen ratings? What are Nielsen ratings for? Starts with a T and ends with a V. TV! He got it! Okay, and what are the trends, and what are people watching, and so on and so on and so forth. But if you don't have a small sample set that represents the rest of the population, then the survey is not really valid. So that's why I said, assuming this survey was accepted at a high level of confidence, we're going to do confidence intervals later. Sounds exciting. To emulate the trends of the general population, yeah. We got to figure out what all is involved in that as we go through the year. But anyway, how many would prefer to listen to pop in a new survey of 550 people? What could we expect? Well, it's very simple. Pop was the last one that we had. It was 0.097 or 9.7% of the people. And if that was a valid survey that represents other parts of the population, then 9.7% of these 550 people should also like pop. So basically, you multiply those two and get an answer. Whatever that answer is, I'm not going to ask for it. Okay? All right, so I like that. And then the last thing, the last two questions in your homework ask what kind of situation would dictate a particular picture. Obviously, the line graph is very specific, what I just covered. Line graph actually would be best when we have trends over time, like as things build. So we could use a line graph to do that. Whereas a stem and leaf plot and a histogram, and even, in a histogram, that would be best probably for, tests in a class. But here's some general things that the book says, and then you read 41 and 42, and then you, from thinking about what those graphs have been over the last couple days, what kind of situations would be best for each one, using this as an idea. So again, I'll go back to that homework. There's your pictures. That's illegal. Just put you on the internet. 17 and 18 are histograms from yesterday. I think 31, 33 are line graphs. Only one has to be created, 33. 35, 37 are pie charts. 41 or 42 are this charts. When do I use a particular situation? All right, I'm done. Okay, I'll leave you alone now.